We have with us Mr. Samir Somaiya from Godavari Biorefineries Limited and Professor G.D. Yadav from ICT Bombay. Good afternoon, sir.
Good afternoon.
Today, you have inaugurated the pilot plant of Dimethyl Ether. Before that, you did a R&D evaluation of Dimethyl Ether. So, if you can talk about, sir, about the R&D that you did at ICT Bombay.
You know, one of the problems which I've been handling at ICT is, circular economy, then net zero. I'm also talking about carbon dioxide refineries and net negative systems where, instead of carbon being taken up, that is whatever carbon you generate in the form of CO2, it is converted into something else, so it is called carbon neutral. I'm saying we should take out carbon from the atmosphere or whatever sources are there, and that should be used to make something else. And these are catalytic processes, both biocatalysis, chemical catalysis. So the project of carbon dioxide to dimethyl ether is one such idea. So we had already worked on carbon dioxide to methane, carbon dioxide to ethane, carbon dioxide to mixture of hydrocarbons, then LPG, and we are also working on carbon dioxide to sustainable aviation fuels. So that is one important project. But in that, dimethyl ether was very interesting because dimethyl ether as a fuel is very attractive because you don't require additional infrastructure. Same LPG pipes can be used where either you blend DME with LPG or per se you can use DME. Also, it can be mixed, like Government of India has a policy where they use bioethanol in petrol and diesel. Dimethyl ether can be used because it is oxygenated and also it is a very important product which is coming from a waste. So that is the best part of it. So once I had a chance meeting with Mr. Samir Somaiya, and I said, we have developed this process in the lab, and would you like to join us, in taking up to the next level? So it appealed to him because he said that time they were making some 300 tons per day of carbon dioxide from the fermentation plant, and now I think it is 450 or something. So that carbon dioxide, goes into the atmosphere. It may be carbon neutral because you are generating ethanol from biomass. So I said, why not valorize it? And so this I wrote several articles also. I said, why not have carbon dioxide refineries where this carbon dioxide will become tomorrow's feedstock for chemical and allied industry, for which you require hydrogen. That hydrogen can come from any source. It can be a co-product of some process where dehydrogenation is done, or it can come from chloralkali industry, or it can come from biomass also. Okay, but that hydrogen, so-called green hydrogen, if you take it from water splitting, it becomes very good because both hydrogen and oxygen are useful feedstock for converting waste biomass, including agricultural waste, municipal waste, any waste where there is a carbon, that can be converted into valuable chemicals, fuels, materials by using hydrogen and oxygen. And one of the best example is this, that in any biomass you have cellulose, hemicellulose, lignin. Normally people burn lignin, so-called cogen process in sugar factories. So what I'm suggesting, I'm saying to the farmers, don't burn your agricultural waste. Condense it, densify it, make into pellets, and those pellets can be used for converting into these processes where I may have aqualysis, thermolysis, whatever. So you by reacting in the presence of water, you get different products, or hydrogen, and you get very good quality products. So cellulose, hemicellulose For example, cellulose, I can get 6 different sugars, C5, C6 sugars, that can be my feedstock, and I can again use hydrogen. Or I can use biomass and use hydrogen and oxygen, convert into very valuable chemicals. We don't have to burn it. So that, is a good concept. And so I say that, like in India, we have sugar factories, right? And cooperative sugar factory was started in this area, Vikhe Patil, with Vikhe Patil. Actually, I'm telling you, if they had advertised that time that Muhammad Yusuf of Bangladesh got Nobel Prize, right, for cooperative movement. This guy started it much before that. He was the originator of this cooperative movement in India. So I am saying now let us have a cooperative movement where agricultural waste is pelletized, densified, and then it is so farmers give income. Suppose eating 6 rupees a kilo. Government can give incentive 10 rupees a kilo, and take that. So pollution will be there, avoided, and we can take it as a feedstock for a future chemical and allied industry, because we will not have crude oil. By 2050, it will be all exhausted. So dimethyl ether is one such idea where a wasteful carbon dioxide we are converting into a very valuable fuel. And that is our government of India's policies. We want to reduce the foreign exchange we import, we want to reduce. We are importing so many things, so why not do this? With that idea, I had a talk with Mr. Somaiya, and he said, yes, let us do it together. And that is how we decided that, because I had done it in the lab, but I said scale up is required. And the same plant which you have seen today, we can use it for something else also. So that is an investment in R&D, but it's a very good investment. So I must thank him for giving an opportunity to us.
So, Samirji, as a funding partner for Industry Academia collaboration of ICT Bombay, you are working on dimethyl ether, which can act as a substitute for both LPG and diesel, and also can be blended depending upon how things go fast. So, would you talk about what was the reason for that interest first, and second, how do you see this dimethyl ether going forward?
Firstly, we are a funding and knowledge partner. To go from the lab scale to the pilot scale, we have worked closely with Dr. Yadav and his team, and jointly along with our staff, we have put and implemented this pilot plant. We are strong believers of the green transition. It is our belief that the current mode of being reliant on fossil has to change. Our government has made our Prime Minister has made a commitment, and India has made a commitment that it will be net zero by 2070. As India grows and develops towards the Viksit Bharat, its need for resources will grow. In that increase in the need for resources, we are seeing an opportunity by using carbon dioxide, which is emitted today, and using it as a feedstock to meet the needs of our energy and chemical needs. So that's how we look at it. As a company, Godavari emits a few hundred tons of carbon dioxide. This can be valorized by combining it with hydrogen, which in our sugar facility, with surplus electricity, we can electrolyze water. Later on, we can look at other sources of hydrogen. But combining the two, we see a great opportunity in making dimethyl ether, which is a substitute for diesel, LPG, and also can be used as a feedstock for higher value chemicals. India today imports diesel and LPG. As part of this green energy transition, we are seeing a great promise in this technology. We are seeing it not only for Godavari Biorefineries, but we are seeing great promise in this for the country as a whole to meet its energy needs as well as mitigate climate change, and also it will have a global impact.
So today you have launched this pilot project of dimethyl ether. How many months are you going to run, and when do you see this being commercialized on a large scale?
So Dr. Yadav has done a wonderful job in developing this in his laboratory. The next step after a laboratory work is done is to do it at a pilot scale, where we can optimize what it would need to be done when we do a final scale up. Today we have inaugurated the pilot plant, and it is our expectation that over the next 3 months, the engineers and the scientists will work on this to get a better understanding of the reaction and its performance in this pilot plant. Post that, we will have to sit together on the table and look at designing a scale up. So I would say that the pilot phase should take, as an estimate, 3 months. It could be a little earlier, it could be a little later, but we would estimate 3 months for the same.
Dr. Yadav, you talked about this being an indigenous technology, and you also said that it is the first time in the world that these technologies are being developed on a pilot scale and later on to a commercial scale. How do you see the global scenario, and how can India lead the dimethyl ether way moving forward?
You see, there are two issues. Carbon dioxide hydrogenation is very energy intensive. So the type of catalyst which you develop, because this has to go through the route, inside it may go to syngas, it may also go through methanol, and that dehydration, the kind of catalyst which you have developed, it combines all these reactions. Normally they would do the other way around. Syngas they take and then go to the methanol route. So here, one interesting thing I tell you that in this case, we have to have the type of catalyst, process conditions, such as the so-called WHSV or the so-called temperature. Everything has to be such that it gives exclusively dimethyl ether. But argument's sake, because it is going through that methanol route in situ, even if there is some methanol, because it has to be dehydrated, it doesn't bother me, because ethanol is also equally valuable co-product. Okay? So, extending this argument, I can also tell you that by changing the process conditions, I can make in this methane also, which is a fuel. Or LPG also I can make in that by changing this. Okay, dimethyl ether is easier than that. And secondly, once I do that, I will have a grip on the entire process. Correct? Why we are saying that we have done? Because our catalyst is unique. If somebody else is doing with some other catalyst, good luck to them, because I cannot say that they are not working. Certainly some people are working, maybe Chinese are working. But it is not reported the way we have reported, and our stability, on so-called on-stream stability of the catalyst, which doesn't decay for 3,000 hours, for example. So these are some of the things in which in our process, that process makes it unique. Therefore, we are saying that we are the first to do in that way. It does not mean that others don't know it. Others do know it, but they don't have the kind of catalyst and conditions which we have developed. They have not done it. This is number one. Number two, because we want to decarbonize the economy and we are committed to the so-called net zero by 2070, and many companies, like many oil PSUs, they are also committed to net zero by a certain date, before 2050. They will be obviously interested in the kind of technology which we are developing. And also we will reduce the import, crude oil import. or LPG import. That is, and so government of India would be looking at us. If suppose you publish this news tomorrow, I can assure you that many people will ask us. That is one of the reasons that we were given this KV Mariwala, award. But that was the reason, because it is uniquely done.
Sir, one question which is not directly related, but I see a lot of power plants using coal, and they come up with a lot of carbon dioxide. A lot of steel plants come up with a lot of carbon dioxide. Are you trying to see some co-synergy or some synergy between these plants and with dimethyl ether so that we can reduce the carbon dioxide?
See, CO2, if with the success, if this technology is successful, then CO2 is a valuable raw material. Dr. Yadav mentioned it as a CO2-based biorefinery as well. So it could be a CO2-based refinery. Biorefinery because it's coming from biogenic carbon. Refinery comes from any carbon. So ultimately, energy is required for any nation. A CO2 capture and conversion into dimethyl ether for energy becomes its own circular economy. And so we definitely see a wider application of this from not only our industry, but the wider CO2 emitting industry in India and the world.
So how are you planning to work in the pilot stage?
One step at a time.
Okay.
I think it is always good to be one step at a time. That's what we did. We meet often and we share ideas. We have common cause in moving towards a sustainable transition and looking at biomass as a feedstock. So last year this conversation happened about this, and I'm delighted that we have completed the work and he has done it in the lab. Now we are working in the pilot scale. A good time would be to once again for us to regroup after, while we do this, and with success, then we again take the steps forward. But successful completion of the pilot would be a right time to then explore what is going, because then we will have data, we will have something to talk about and its applications.
And sir, have you already patented or?
Part of that, yes, but we develop henceforth something different. We'll patent it together. That is our MOU.
So all the best.
Thank you so much
for your pilot project which you have done in Sakarwadi, Godavari Biorefineries, with active participation from.
It's not only active; it is a joint working.
Actually, I must tell you. Sometimes what happens, we generate many ideas, and if there is no end user, it doesn't happen overnight. It requires a lot of patience. There are failures and successes, but yes, I'm sure that we'll be successful. The best part is, Mr. Somaiya is a chemical engineer. He understands thermodynamics. He understands things. He understands deactivation of catalysts. So I don't have to educate him. In other cases, you have to educate because the owner is some chartered accountant. How do you educate that? That is the beauty. And the company management is willing, we can do wonders.
So this is a good synergy, industry academia synergy. And also I see, industry funded by more of a collaborative knowledge transfer that is happening, which would be good for India once this pilot gets completed. So once again, thank you
both
of you for talking to Indian Chemical.